The James Webb Telescope has recently sent a dazzling message that has left all NASA scientists amazed. The greatest optical telescope in space has been observing different parts of our gigantic universe for a seriously prolonged time, spent discovering various eccentricities. However, the new picture, it has caused a wave to pass through the world of science and astronomy. What startling image has the James Webb Telescope captured? Could it have imaged an extraterrestrial spacecraft in the farthest reaches of space? Come with us as we investigate the alarming new photos taken by the James Webb Telescope. It has unveiled images we have never seen before. If you're excited about staying completely informed about news from the universe and the ecological parts of it, like this video, subscribe to our channel and turn on notifications. NASA's $10 billion James Webb Space Telescope launched using the European spaceport in French Guiana, when it arrived at its new infrared observatory, is a grand house. It provided dazzling views of the universe to analysts and stargazers as the greatest and most advanced space telescope up to this point. Researchers have been ecstatic to see the first scientific pictures captured by the telescope. What they saw nearly left them frozen. When the James Webb turned its instruments toward the well-known pillars of creation, it captured the well-known dust clouds in admirable detail. These pillars are located in the constellation Serpens, around 7,000 light-years from Earth. Pillars of creation are part of the Eagle Nebula, massive clouds of gas and dust that were first imaged by the Hubble Space Telescope in 1995. Since then, the pillars' brilliant light has been revealed. The new photograph captured by the James Webb Space Telescope uncovers even more of the pillars of creation's critical detail. Some stars are visible that were not found in the previous image captured by Hubble, some of which formed 2 or 3 years ago. This symbolizes a significant scientific advancement. Additionally, the James Webb Space Telescope examined the so-called Pandora's Cluster in a stunning image named following Greek mythology. Pandora's Cluster is a region predicted by Albert Einstein in 1915. These new pictures astonish scientists as they disclose specifics previously unknown in this region of space. But it's important to keep in mind that this area of space has a formal reference is Abell 2744, which is part of the Pandora cluster. This cluster houses a combination of distinctive structures. What makes it so captivating is within it. This image is that it's been seen before. However, only the center of the space has been examined by the Hubble Space Telescope. This suggests that various cosmic secrets still need to be found in this fascinating part of space until the James Webb directed its powerful instrument for the area and infrared to observe the Pandora cluster. The big telescopes were used by the observing team, near-infrared spectrograph, and near-infrared camera as part of the Deep Observation program. Before the epic images of ionization were taken and then combined into a panoramic image, this panoramic image revealed around 5,000 sources of infrared light in the cluster in Pandora, which is about 3.5 billion light-years away. The image captured by the James Webb Telescope achieved a remarkable convergence between width and depth, which may change our view of cosmic evolution. A highlight of the image is a bright foreground star in the Milky Way, whose remarkable pattern of diffraction was created by the James Webb Space Telescope. Additionally visible are excellent sources of white light surrounded by a hazy glow, corresponding to much more distant galaxies that are part of the Pandora cluster. Although human-made technology is essential for this observation, astronomers of galaxy clusters also used a natural event suggested by Albert Einstein's theory of gravity, known as general relativity. Published in 1915, it also saw fascinating discoveries that continue to excite scientists and space experts. The James Webb Telescope has captured bizarre cosmic events that cannot be fully explained by experts. Such a mystery is the baffling concentric rings found around a distant star, which still cannot be completely understood by space experts. The image was posted on Twitter by a citizen scientist, sparking a storm of comments and debate among the online community. The picture showed a star called WR140, surrounded by regular wave-like circles that gradually faded. What was striking was that the circles were not perfectly round, but had a somewhat square appearance. This immediately led to speculation about a possible origin from another planet. However, it was argued by some analysts that it was simply the work of nature. To accomplish what appeared extraordinary when viewed from a single perspective. Sometimes natural phenomena may appear stunning from certain points of view, but simple explanations remain. Questions persist. Why do they possess that particular shape? And why are they so uniform? Experts have been troubled by questions like these. Mark Makorian is an interdisciplinary researcher working in the JWST Science Group and a science advisor to the European Space Agency, called it surprising in a Twitter thread. He explained that the sharp blue pattern is an artifact due to optical diffraction from the bright star WR140 in the image. Nonetheless, he noted that the red bend is real and represents a series of shells around WR140 in space. Despite the fact that NASA is expected to supply an explanation soon, young stars generally tend to shine a brilliant blue. As they age, they become more reddish in color, cooling cosmologists by burning their fuel. Scientists did not expect to see old red stars in the early universe, for which the James Webb Space Telescope was designed, nor did they anticipate seeing galaxies up to 1 billion times more massive than the Sun. These visible red spots in the images taken by the James Webb Space Telescope appear to be many times more massive. In Jan Kai's opinion, the most massive galaxies in the sample are estimated to have masses between 2 and 4 times less than that of the Milky Way. She said this discovery is astounding since galaxies as large as ours were discovered when the universe was only 3% of its current age. Leah mentioned that prior to cosmologists beginning to adjust cosmological theories to explain how these galaxies formed so quickly after the Big Bang, they will need to make certain that the unusual red spots they are looking at are not something else. Nonetheless, alternative explanations would also require entirely new ideas. For example, stars in the early universe could emit light in unusual ways due to a lack of heavy elements not included in our models. The images that revealed these mysterious galaxies were obtained by Webb's near-infrared camera as part of the Cosmic Evolution Early Release Science Program. The team plans to return soon to these galaxies and to obtain the spectra of the Abell 07-3 cluster. Smack the spectra. Light from distant sources decomposes the observed light according to its composition into frequencies, thereby revealing the chemical and physical properties of its source. Notably, the spectra provide very precise distances from these objects. The nature and distance of these things are interdependent, and if we are aware of the distance, we can pinpoint their characteristics. Leah states that just a few months after Webb's team released the initial observations, scientists are being forced to revise theories about the early universe. Observing the early universe prompted us to discover, for the first time, something that is so astonishing that it poses problems for science overall, as it challenges the entire picture of early galaxy formation. Another amazing image captured by the James Webb Space Telescope is the Ghost Galaxy. It's visible through the telescope, which looks like a whirlpool turning before our eyes. This new image, based on deep space data, highlights the dust lanes of the galaxy NGC 628, or M74, which is also called the perfect spiral, due to its symmetry. The Ghost Galaxy is enticing from a scientific point of view as a result of the massive black hole at its core, according to scientists. Despite the Ghost Galaxy having been imaged several times, including by space observatories like the Hubble Space Telescope and the Spitzer Space Telescope, Webb's images stand out due to the light in the near-infrared that revealed a lot of dust, along with the strength of its singular 18-segment hexagonal representation of the James Webb Space Telescope. Hailed as one of the most ardent devotees of space exploration, it continues to amaze scientists with its extraordinary skills and discoveries. Launched with a mission to uncover the deepest secrets of the universe, Webb has not let down by its initial observations. Observations gathered through the complex details of faraway worlds, from exposing phenomena that were previously unknown, to the contributions made by the Webb 2 space science, are rewriting our school's textbooks. Understanding one of the telescope's remarkable achievements is its ability to look into space, further than anyone else by harnessing another instrument before it. Its advanced technology in the infrared, utilizing a large mirror with 18 segments, has opened a new realm of exploration. In contrast to its predecessor, the telescope, which primarily operated in the visible and ultraviolet spectrum, the Webb, because of its infrared capabilities, can penetrate cosmic dust and observe hidden celestial objects from view. Telescopes have demonstrated this ability, which is important in its observations of iconic building blocks within the Eagle Nebula. Webb's infrared gaze uncovered unprecedented details of these immense columns of dust and gas where newly formed stars emerge. The telescope's ability to see through thick nebular material provided astronomers with clearer insights into the processes of stellar birth and evolution. Additionally, Webb's observations of clusters of galaxies like Abell 2744 and Pandora's cluster have shed new light on the large-scale structure of the universe. By capturing thousands of luminous sources inside these clusters, Webb has enabled astronomers to study the formation and evolution of galaxies across cosmic time. The deep field images obtained by Webb not only expand our understanding of galaxy cluster dynamics, but also challenge existing models of cosmic structure and evolution. One of the most intriguing discoveries made by Webb is the presence of ancient galaxies that defy conventional cosmological theories. These galaxies were discovered when the universe was just a small fraction of its current age, and their populace rivals or exceeds that of the Milky Way. Such results raise fundamental concerns about how galaxies assembled and grew in the early universe. The James Webb Space Telescope JWST is quickly becoming a focal point of astronomical research, significantly enhancing our knowledge of the cosmos. One of its most significant achievements is its ability to capture light from some of the earliest galaxies. This ability exists everywhere in the universe, based on the advanced infrared technology of the Webb that makes it possible to observe objects in the sky that are too faint or too far away for other telescopes. Webb's observations have revealed new insights into the formation and evolution of these ancient galaxies, which offer a deeper comprehension of the early universe. Recent Webb-sourced images of the universe show galaxies in various stages of formation and development. For example, the Webb has captured intricate details of early mergers of two or more galaxies. When galaxies collide and interact, these mergers are significant life events in the cycle of galaxies that affect their structure and star formation rates. The telescope's detailed observations of these processes are benefiting scientists, completing the galaxy's history of formation and offering a glimpse into how galaxies like the Milky Way have evolved over billions of years. In addition to its observations of distant galaxies, Webb has also focused on nearby celestial objects, like star-forming regions in our own galaxy. The telescope's ability to see through dense cosmic dust has allowed astronomers to investigate the development and birth of stars in unprecedented depth. For example, Webb has provided new views of regions like the Orion Nebula, one of the most active and closest star-forming regions to Earth. These observations are assisting scientists in comprehending the complex processes involved in stellar birth and the development of planetary systems. Another important part of Webb-based research is the study of exoplanets. The telescope's infrared capabilities are especially useful for analyzing the atmospheres of exoplanets, allowing scientists to detect and characterize their compositions. Webb has already begun to investigate the environments of several exoplanets, supplying information on their temperature, atmospheric composition, and even possible indicators of habitability. This information is essential for determining planets where life could exist. In understanding the conditions that survive on distant worlds, Webb's contributions to the study of planets extend beyond exoplanets. The telescope has also looked at our own solar system, including planets, moons, and other small bodies. For instance, Webb has observed the ice giant Uranus, providing new insights into its atmospheric structure and weather patterns. The telescope's observations of distant comets and asteroids are also helping in understanding the early solar system's conditions and the formation of these minuscule celestial bodies. Additionally, telescope observations have led to important insights into cosmic phenomena like dark energy and dark matter. While these enigmatic parts of the universe remain elusive, Webb's detailed images of galaxy clusters and large-scale structures provide beneficial data that can help scientists infer their properties. by investigating how galaxies and clusters interact and evolve. Astronomers aspire to improve their comprehension of the roles dark matter and dark energy play in the universe's structure and expansion. Webb's deep field observations are particularly noteworthy. These observations involve looking at a tiny, empty space in the sky for long periods to detect faint and distant objects that are otherwise too dim to observe. Such observations have revealed a wealth of information about the beginning of the universe, including the initial formation of galaxies and the development of cosmic structures. These deep field images are not only a testament to Webb's observational capabilities, but also a window into the early universe. The James Webb Space Telescope has also made significant strides in studying cosmic dust. Cosmic dust plays a crucial role in the creation of planets and stars, and understanding its properties is essential for comprehending a variety of astrophysical processes. Webb's ability to observe dust in high resolution has provided new insights into its composition and distribution, shedding light on how it influences the formation of celestial objects. Webb's technological advancements represent a significant leap forward from its predecessors. Its large segmented mirror allows it to collect more light and achieve higher resolution images than any other telescope can capture. Additionally, its advanced instruments, including the near-infrared camera, ANACAM, and the mid-infrared instrument MIRI, are designed to work together to cover a wide range of wavelengths. Providing a comprehensive view of the universe, the telescope's mission is not only to observe, but also to help answer some of the most fundamental questions in astronomy. For instance, one of its most important goals is to investigate the origins of stars, planetary systems, and galaxies by observing the universe in its infancy. The goal of the Webb is to answer questions about how the first stars and galaxies formed and their transformation into the structures we see today. The James Webb Space Telescope has already established a significant influence on the field of astronomy, and its mission is expected to keep producing groundbreaking discoveries for years to come. As scientists examine the data provided by the Webb in greater depth, they will discover new aspects of the universe, challenging existing theories and refining our understanding of cosmic processes. The telescope's contributions will undoubtedly shape the future of astronomical study and broaden our understanding of the universe in ways that were previously unimaginable.